hypothesis testing a lot, right? We have our 6 steps. We're going to follow those 6 steps a lot. Okay? Stating our null and alternative hypothesis, getting our alpha level, calculating our test statistic, go SAS. Getting our p-value, again, we get that straight off of our SAS output. Rejecting or failing to reject our null hypothesis based on our p-value and our alpha level, and then turning that into some type of business conclusion so that we can actually answer our business question. We've talked about a mean compared to a population. We've talked about a proportion compared to a population. We've done all sorts of wonderful, crazy, fun things. Are we ready? Let's move on. Okay. Last time we talked about comparing 2 means to each other, so 2 groups, the averages of 2 groups, when they were independent groups. Okay, so it's a 2-sample t-test, it's an independent t-test. Different textbooks, different courses, depending on what you go to, what you read, we'll call it different things. But a 2-sample t-test or an independent t-test. And really the idea is, does the mean of one group equal the mean of the other group? Our null hypothesis we're going to test. You could do a little algebra and subtract the mean for the second group on the other side. I generally don't do that, just to kind of differentiate between our 1-sample test or what we call a paired, matched, or dependent t-test. That's what we're going to talk about today. So the sample mean compared to a different sample mean. When our 2 groups are dependent on one another, whether they're matched, whether they're paired, these are all words that are going to be synonymous. What we're looking at is the difference between the 2 groups equal to 0? Theoretically, there could be a value there, but the majority of the time, the vast majority of the time, we're just trying to say, are these 2 groups different? And if the 2 groups aren't different, if their means are not different, if the mean for group 1 is 10 and the mean for group 2 is 10, 10 minus 10 is 0. 0, yes. And so that's where the 0 is coming from. Notice that we can do group 1 minus group 2, or we can do group 2 minus group 1. It's very important for us, when we're talking about dependent t-tests, to state which is group 1 and which is group 2. Because this really makes a difference. We'll also see the mean was just a D, which stands for the difference between the 2 groups. All of these are appropriate null hypotheses. Okay. Questions, comments? We're also going to talk about this a little bit. We've already actually talked about this with the independent t-test. The idea that we can have 2 variances that are equal to each other. Or we could even go on and do 2 proportions that are equal to each other. So this is all about just 2 groups on some statistic that are equal to each other. The sample variance, we're going to be able to use SAS, and we'll have 2 different options to do that. Without tremendous coding, I haven't found a good way to do a sample proportion, 2 sample proportions compared to each other in SAS. So that's why it's grayed out. Yes, you can do it. Yes, there's formulas to do it, but we're not going to focus on it. So if for some reason you want to do that, let me know and we can kind of go over the coding, but it's not just a nice point to click like all the other ones are. So here's our nice little summary slide of how we're going to get to this. All of it's going to be going through the Analyze, ANOVA t-test, and we get to choose whether we want a 1-sample t-test, a 2-sample t-test, or SAS is going to call it a paired t-test. To find the variance, when we do our t-test, our independent t-test, we get a test of variances for free. We can also use the ANOVA feature, which we're really going to focus more on next week. So there's a couple different ways that we can tell if 2 variances are different from one another. So last time we talked about independent t-tests. 2 groups are completely independent of one another. You guys had that as a question on your quiz that was due today. So we can look at one group gets our old ad, one group gets our new ad, and we can see is one group better or less than, greater or less than the other. In terms of our dependent t-test, here we have a group where we have repeated measures are taken. Right, so the dependent t-test, when we use this, is like a pre-post test, a before and after. Okay, so that's why they're paired. Generally, it's the same subjects, and you're taking multiple readings on that same subject. Okay. We're checking, we're putting little mice through the rat, or the rat through the maze, and we're testing the time, and we're trying to see if the average changes. And we're going to have trial 1, 2, 3. Okay. So the idea behind dependent is this repeated measures idea. Okay. The other option for dependent or paired t-tests could be that I find subjects that are very, very related and pair them together. So I could do something where I have a married couple, right? I have a husband and a wife. And so they're paired together. I pair their scores, right? It could be in medical trials, if you get twins, that's awesome, right? So control for as much stuff as you have. You have twin A and twin B, and A gets the control and B gets the treatment, and you see what happens. But you keep their scores together, okay? And so they're not completely independent. We've actually paired them based on some criteria. So that's the idea behind dependence. Either repeated measures or your subjects are paired on some certain criteria. So here, our subject sees the old ad. So here we have one group sees the old ad and one group sees the new ad. Completely separate groups. Here we have a subject sees the old ad, and then the same subject sees the new ad. Okay. So our null hypothesis can be before, right? So it's the same as we had before. Their old one, is greater than or less than the after. So their change in how they're feeling about our subject, or how they're feeling about our topic, is what we're going to measure. So we're not just measuring their score, their satisfaction score. We're measuring the change in their satisfaction score after they've seen our ads. Does that make sense? Do you have any questions? So when we're doing this, here I have before is less than after. So if I subtract, and I move it over here, before minus after is greater than or equal to 0. Before minus after is less than 0. Here, a negative value is a good thing. Why would a negative value be a good thing in this scenario?
You made an improvement. That's what you want.
Right? That's what I want. So if my satisfaction score before was 5, and after it was 10, and we're assuming a bigger score is better, 5 minus 10 is a negative 5. So a negative number means I've made an improvement. Right? If I flip my scenario, and now I do after minus before, 10 minus 5, do I want a positive score or a negative score? Now I want a positive score, so now a positive score is good. Okay? This is important as we go to our interpretation. Okay? So the way we subtract this makes a difference. And in SAS, you get to determine which you subtract. If you do before minus after, or after minus before. Okay? A lot of times you'll want to do after minus before, because then it's common sense, right? It makes more intuitive sense. Positive numbers mean it's better, negative numbers mean it's worse. A lot of people, however, will do this piece, before minus after, and then you've got to get it in your head that a negative number is actually a good thing. Okay, so when it comes to interpretation of these dependent, these paired t-tests, this is going to be something that's going to be very important, which is why labeling becomes very important. Questions about comparing two dependent means? Yes?
With the same element, would it make sense to actually have a different sample set, which is the difference, rather than taking the mean of this and taking the mean of that?
Absolutely. Yes, you can totally do it. So here, we're talking about one group versus another group. But when I went back and I said, or you could write it like this, you could actually just have a sample set that is the mean of the difference. And then basically you're doing here you're doing a 2-sample test, and now here you're doing a 1-sample test. Absolutely. Does that make sense to everybody? Absolutely. Alright, so a couple of different things. As far as SAS goes and as far as SAS cares, right? So at the top right, you have the analyze, ANOVA, you're going to do a t-test. If you go to the bottom, if we're doing independent means, we're going to do a 2-sample test. your output's going to look like this. So the choices you're going to have to make is you have to have an analysis variable, you have to have a dependent variable. Right? So this analysis variable is your dependent variable. It's the outcome, it's the thing you're measuring. Okay? Your classification variable is your independent variable. Okay? And it's your classification, it's your category, it's your groups. Okay? So because of that, and the way that we want this to work, your data have to be set up so that your independent variables in one group and your dependent variables in another group. If your data aren't set up this way, you're not going to be able to do an independent t-test in SAS. For a dependent t-test, first part's the same, analyze ANOVA t-test. Now we're going to pick the paired, and you'll notice that it has the little D right there, so the mu sub D. Okay. Now we have roles. We have our two paired variables. Okay. This is where it's important. We're going to do the top minus the bottom. So if you want to do method 2 minus method 1, or if you want to do method 1 minus method 2. So it's going to take the top and subtract it from the bottom. In this case, we need our data to be set up as the one on the right. You need a column for group 1 and a column for group 2. So the same data may have to be formatted two different ways for you to be able to actually use SAS, depending on if you're doing an independent or a dependent t-test. In some cases, I'm very nice, and I actually gave you two different files, and you just have to pick the appropriate file. Right? In some cases, I'm not as nice, and you have to manipulate your data. For your homework assignment, I'm nice. If you want to do a dependent t-test in your project, well, I can't help you there. However, I can help you there because as we've been playing and learning and doing all the fun things, it was actually while I was trying to investigate the date-time column, I wanted to be able to split the date into one column and the time into another column. And SAS actually has a function called split columns. I was so excited. That's not what it does, though. But what it does is it will actually take the data that's set up in our independent-dependent idea, and it will transform it into this group 1, group 2 idea. Okay? So you don't need that to be able to do the assignments, because for the assignment, I've given you both options, both sets of data.